Right. Well, no. It would be like 180 minus 35. Okay, so here is my example. Let's say they give us draw 0 to 5 degrees. Okay, so for some reason when they use true bearings, you have to have 3 digits. Significant figures, I don't know what it is, but if it's 100 degrees, they just say 100 degrees, but anything less than 100, they throw a 0 in front. Don't ask me why. Okay, so, I guess, yeah, 0500. Yeah, you're right. Similar. Maybe the military came up with this, who knows. Okay, so here's the same compass. Okay, so if I'm going off of north, okay, what direction is clockwise?
It's towards east.
Okay, towards east. So towards east, I'm going to go 25 degrees. So this angle right here is going to be 25 degrees.
Physics is different. When we learned it, that east was the starting point going counterclockwise. So
that's horizontal bearing.
Oh, okay.
So if they use horizontal bearing, they do use that one too.
Or you're writing that one down too.
Might as well.
Okay, well, what the heck do you do with that one?
So horizontal bearing is...
No, I'm talking about this one. You just did.
That's it. That's all you do.
You
That's
just start at north and you go 25 degrees from
clockwise. Yep.
Check.
Okay, so horizontal bearing is just like how you would do the unit circle. So that's how I would think of this one, like the unit circle.
Is this our last bearing?
Mm-hmm.
Are we done after
What
this?
is that?
Okay, so horizontal bearing, that's the unit circle. So like if you had 60 degrees, it's like the unit circle. Like, so it starts at east and then goes upwards. Yeah, so it starts at east and goes upwards. So if it said 60 degrees, a horizontal bearing of 60 degrees, you'd go up from east at 60 degrees.
And it's just labeled at 60 degrees.
Right. That, yeah, that's for true. Okay, so I feel like we got all those. No, we're not. I got a ton. Okay, so here's what we're gonna do with Geogebra. So everybody get your Geogebra. And we're gonna do this story problem.
About 12 minutes or 12 miles?
Miles. Okay, so everybody ready for our real-world scenario that we're going to measure out using Geogebra?
Heck yeah.
Okay, so first of all, take a look at the problem. Okay, so it says Tia walks north 50 degrees east for 12 miles and then walks 8 miles due east. How far and what quadrant bearing is Tia? Okay, so this whole section is like here, let's do the math by using lengths like protractors and rulers. Okay, so instead of actually pulling out protractors and rulers, we're going to use Geogebra to do that instead. Okay, next section we'll use it using cosines, log cosines, and such like that. Okay, so we ready? Everybody got Geogebra open?
No, not yet.
Don't update it.
Don't update it?
No, because it's a whole separate file.
Oh,
Unless you already did.
This is Geogebra account.
Don't create an account. Just say no.
Geogebra.
Okay, so what we're going to do is we are going to start with creating a vector for the first sentence. Okay, so the first sentence said 50 degrees east, northeast. So if I was thinking about that, it goes from north, 50 degrees east. Okay, so from the north, and we're going 12 miles. Okay, so if I go to Geogebra, this is what I type. Okay, so I'm going to use some variable to represent my vector. Let's use u. So down at the very bottom of the page, there's an input bar. So make sure you're in the input bar before you start typing. Okay, and you're going to go u equals, and then you're going to do a parenthesis, which is not a 9, parenthesis. I haven't even hardly done anything yet.
No, like, my tablet's all screwed.
Okay, well look up for now. Just pay attention. Okay, and then what I'm going to do is I'm going to enter the magnitude and then the direction. Okay, so the magnitude was 12, and then I'm going to separate it with a semicolon. So semicolon, and then, okay, now be careful. When the Geogebra measures angles, it always goes off of the due east. So the horizontal one. So we want 40.
Why would it be 40?
Okay, because
Oh,
if we're, you have to go 90 minus 50, because northeast would be off of this way, but if the Geogebra is measuring this
So
angle,
basically
we
you just
want
always
40.
take 90 minus whatever number.
It depends on the bearing they give you. Yeah. Okay, so what happens when I do this? I have no idea why Geogebra doesn't like the way I input it, but it at least gave me a vector that I can adjust. So if I take my stylus and see the gray, do you guys see the U equals, that gray? If I highlight it, push my pen on it and basically right click, go down to object properties, hold your pen, just hold it on there. Properties, and then I can go into the value, go to object properties,
Whoa. Definition, 12, and you gotta just go 50,
40.
40?
Yeah, because remember it was northeast 40, so it's up here, but Geogebra is going to label off of the x-axis. So you have to go 90 minus 50. I don't know. That's just how Geogebra does
40,
it.
that's it?
You do.
No, you just typed in 40. So I'm going to squeeze my window so I can see my whole vector.
I got mine going today.
Now what do we do after? Because I'm clicking enter and it's not working.
Oh, just exit out and it should adjust for you.
I got mine going left.
Okay, so with your stylus, put your pen,
I've already done that. Put the 12 before you.
oh, hit enter and then close out the window. It should adjust it for you.
No, I was
Okay. I'll come around and we'll do this again.
My tablet keeps breaking whenever I try and change the number.
Oh, do I click fix object?
Oh no. Fix object? I don't know. I don't think so.
Okay, I did that last time and it didn't work.
Okay, so now what I'm going to do is I'm going to make the second vector. Okay, so which variable should we use to represent the second vector? How about t? Okay, so t equals parenthesis. I'll come and help you. Oops. Parenthesis. Okay, so what was the magnitude of the second one? 8. So 8 semicolon, and then it said due east. So what angle is due east? 0. Okay, so I'll type in 0 and hit enter. And I don't know why it did that one right, but perfect. Okay.
It's on that x-axis.
It didn't
Right.
show up.
Okay, so now what we have to do, you guys, is right now they're drawing all of our vectors from the origin. But if we are going to find the resultant, we need to put them tip to tail.
Tip to tail.
Okay, so what I have to do is I have to go up and create a point on the tip of my first u vector.
Multi. Oh, I know what I'm doing.
Okay, so make a point on your U. So make sure you use the point tool.
I'm going to.
How do I know that it's at the end?
It is. If you just select by the vector, it'll go straight to it.
My number is different than yours for the point A.
How close is it?
Not even
It's
close.
by 0.2.
There, maybe we should try,
0.92.
try,
0.7.
how about point on an object?
Oh,
Maybe that would be more exact.
maybe.
Let's try it and see. That could be some kind of human error. Okay, so now how do we move the vector? So what you're gonna do is you're gonna use the third on the top toolbar. It looks like a line segment. If you go down to the very, very bottom,
9.05 and 7.59.
okay, the very bottom option says vector from a point. So what I'm gonna do is choose that very last one.
Where?
The third tool, the very bottom. Okay, so it says that I have to select the point and then the vector. So I'm going to start by selecting my point A, then I'm going to select my vector T, and it will create my added vector.
Why is yours labeled B?
Whoa, how did
It just chose a variable, so it depends. You have a
I'm still getting
problem?
way different number for my A.
What are you getting?
I'm getting like 9 and 7.8.
Oh, that's okay. You're not
How
that
do you
far
do
off.
that?
It's really close.
Yeah, but you're B.
So the
like,
third,
it's the same thing.
see at the very top, the little arrow, then I have a point tool.
Okay. How do you move it?
The third one, if you go down, you have to select the point and then the vector, and it'll move it.
So I start by selecting the point.
Make sure you're on the vector to point tool,
Vector U.
and it should move it. So Stokey, look up.
Okay, show me.
Okay, so see how I am on this third one?
Yeah.
You have to make sure you pick the very last vector to point.
Okay. Vector from point, and then I hold.
Yep, now pick point A and then vector T.
And then how do you place point A? Oh,
I
got
was
it. Place point A. And then I go to vector.
Yep.
And I go
You should be done by now.
vector. You got the A there.
Now touch the vector.
Now how do I move this up?
I do that.
You have to use this tool, vector from point.
Vector from point. No, I'm still doing the point.
You're still doing the point?
Yeah.
The point tool is right here, right next to the vector tool.
Whoa. Holy crap.
Okay, I'm gonna come over there in a second. Okay, so now what I have to do is create my resultant vector. So I'm gonna choose vector this time and go from the origin to my point A. Okay, so my resultant vector, you guys, everybody look up real quick. Okay, my resultant vector was labeled W. Okay, but right now it's in a points format, so it's giving me the points. I don't want it to list it like that. I want it to list a magnitude and a direction. So if I highlight on that piece again and come down to polar coordinates,
Wait, what? Are you
Polar coordinates.
happening right now?
that will tell me the magnitude and the direction of my resultant vector. Okay, so the magnitude is 18.6. My angle is, let's call it 24 degrees. Okay, so that's how I would answer my question. I would say
No, couldn't you just use
18.
laws of sine? Laws
Yeah.
of cosine?
Mm-hmm.
Multi, how'd you
I'm
get
not sure you would want to do that.
I'm so lost.
What?
What happened?
That's our, the whole thing.
Where'd you go from B? Like, how'd you make a line from B?
I shaved my hair.
What?
Go back to
Hey, Tom.
your. How'd you get that line, W?
I did it from the origin to the end of my V. I moved B. I just made a new vector.
How'd you measure it? Just so. I got 17.19.
What?
And 7.